Hello everyone, welcome to Lab 9 of CSE 4308. In this lab, we shall be discussing JDBC or Java Database Connectivity. So JDBC is an API that is written in Java and allows us to communicate with our Oracle or any other database by using Java language. So instead of having to directly type into our SQL consoles, we will be using a Java program to communicate or to access our databases. All right, so that's what we will be doing in this lab. However, I am aware that most of you are not familiar with the structure of a Java program as you have not done your visual programming course yet. So what I'm going to do is I am going to explain to you the basic structure of a Java program by comparing it side by side with a C++ program. I know that you guys are familiar with C++ and object-oriented concepts, so if I explain it that way, it should be easier for you to understand Java in general. So let's get started. Right, so first let's take a look at a very simple program written in C++. So as you can see, we have written our include statements, and then we created a class called myClass. And this class has two variables, ID and name, and both of them are public. So we have declared both these variables under the public access modifier. What this means is that whenever we create any object for myClass, that object will be able to access both ID and name without using any getter or setter methods, right? Okay, so next we have our main function. And in this main function, we have, as you can see, we have created our object for the myClass class. And then we have done some simple operations, like we have taken user input for the ID value, and we have used a constant value for the name value. And then finally, we have just printed those values, right? Okay, so now let's take a look at what this program would look like if it were written in Java. So the first thing that we have here is the import statement. In C++, we use the #include keyword to include any extra library or any extra file that we want to include in our final program. So suppose we have some additional functions that we want to use. The way we can include those functions is by including the header file that includes those functions, right? Similarly, in Java, if we want to import any additional library or any additional method, then we use the import keyword. In this case, as you can see, we are using the java.util.scanner package. So we are basically importing java.util.scanner package. In case of C++, IOStream provides us the tools that we need to perform input-output operations, right? In case of Java, this java.util.scanner package allows us to perform input operations, all right? Next, we have public class hello world. So we are creating a class called hello world, right? So this is something that is unique to Java when comparing it to C++, because in Java, it is a requirement that all our lines of code, apart from the import statements, have to be encapsulated by an outer class. So in this case, hello world is an outer class, and all our codes in this file are included or encapsulated by this class. All right. And another requirement is that the name of this outermost class has to be the same as our file name, right? So in this case, the file that we are editing is called hello world. And so the name of this outer class is also hello world. You see, we do not have any such requirement in C++. You can say that the name of our C++ file was main.cpp, and we do not have any class here that is termed main, right? However, in this case, the name of our Java file is hello world.java, and so the name of our outer file, our outer class, is also hello world, right? Next, we have our myClass declaration. So in this case, we have some differences as well. For C++, we did not use any access modifier, right? However, in Java, whenever we declare any classes or whenever we create any classes, we have the option to use access modifiers, right? In this case, we are using the private access modifier. So what this means is that no other class other than hello world will be able to access this my class. All right. Next, we have used the static keyword. So this static keyword basically means that my class is a nested static class of the outer class hello world. So this is a topic that we will not need right now, and we will not worry about this topic since our main goal is not to understand the intricacies or complexities of Java, but to understand Java enough so that we will be able to understand the JDBC code that we will be taking a look at later on. All right. And similar to our C++ program, you see that we have two variables under my class, ID and name, and both of them are public. Notice that in C++ we had to use the public keyword only once, but in case of Java, we had to use it twice for the two type of variables that we have. Next, we have our main function. So in case of C++, we simply wrote int main, and the int basically denoted that our main function will be returning an integer value, correct? However, in case of Java, you can see that we have used public static void, 3 keywords. So the void keyword basically means that our main function will not be returning anything. That is simple enough. However, this public and static are very important when it comes to the main functions in Java. So we are aware that JVM is responsible for managing Java programs, right? Whenever we use this public static keyword, or whenever we use this public static keywords before our main function, our JVM basically knows that this main function is the entry point to our program. So if we did not use this public static keywords, our JVM would be confused as to which exactly is the entry point of our program here, all right? So public static basically makes the life of JVM easier. Next, we have the my object declaration of my class. So this is also different. So in case of both C++ and Java. So in case of C++, we did not have to initialize it. We simply wrote my class, my object, right? However, in case of Java, we wrote my class, my object is equal to new my class. So we are basically initializing the object. In Java, if we do not initialize an object, we will not be use that object later on. So if we wanted, we could have simply written my class, my object, and ended the statement there. However, we would not be able to use this my object, all right? Next, we have the scanner input object. So if you remember, we imported the package java.util.scanner, right? So this package has a class called scanner, and this scanner class has some methods that help us take input from the users, all right? So what we did is we created an object input of the scanner class and we initialized it. During initialization, we passed as parameter system.in, but we will not look at what these parameters mean. Again, that is a topic for another day. Next, we have system.out.println, which is basically the equivalent of cout. So in C++, whenever we want to print something, we simply write printf or cout, right? In case of Java, we use system.out.println, and then we input or we write the things that we want to print. Next, we move on to our next line of code, which is this. So in our C++ program, you can see that we are directly taking an input from the user, and we are storing that input into our myObject.id variable. To do the same thing in Java, we will be taking the help of a function inside the scanner class. So if you remember, the scanner class has a list of functions or methods that allow the user to give input to the program. One such function is called nextInt, and this nextInt function allows the user to give an integer type of value as input, which can be stored by any variable that we want to use. So we know that to access the methods inside a class, we need to declare objects, And in this case, we have declared a scanner object called input, and we will be using this object to invoke the nextInt function, as you can see. So whenever this line is executed, our user will be able to give an input to the program, and that input will be stored in our myObject.id variable. All right. After that, we have myObject.name is equal to a hard-coded string. So in this case, you can see that the syntax is same for both C++ and Java. In this case, we are simply storing a hard-coded string value inside our myObject.name variable. Finally, we have a print statement in both cases. We already have seen the syntax for a print statement in Java. We have used the same syntax to basically print a simple statement. All right. So as you can see, in our console, the output is same. So we are basically doing the same functions, or we are doing the same task in both C++ and Java, where the syntaxes are a bit different, but the output is the same. All right. So now that we understand the basic structure of a Java program, we can move on to our next topic, which is try and catch. So we will be taking a look at a demonstration to understand how try and catch blocks work. But before moving on to the demonstration, let's at first understand why we need to use try and catch blocks. So as a programmer, we know that our program is prone to different kinds of errors, right? In Java, these errors are called exceptions, and whenever our Java program faces any exception, we say that our Java program is throwing an exception. So that's what the terminology is throw exception mean, all right? Now, imagine that instead of, we know that whenever our program faces any error, it stops executing the code at that line of code where it faces the error, and then it says us that compilation has failed or something like that. Now, imagine that we do not want that. So instead of stopping our compilation, or instead of stopping our execution at the line where our program is throwing an exception, we want to execute some alternative lines of code in our program. All right. So the way we can do this is by using try and catch blocks. So inside our try block, we write the lines of code where we think that there might be some sort of exceptions. All right. And in case our program faces or throws any exception in our try block, it falls back to our catch block and instead runs those lines of code that are present inside the catch block. All right. Now, we understand that there can be different kinds of errors or different kinds of exceptions. For example, we can have input-output exception, we can have SQL exception, and so on. We can also have arithmetic exceptions, right? So to handle different kinds of exceptions, it is possible to write different types of catch blocks. So we will be seeing that in our demonstration right now. So as you can see, we are editing try-catch-example.java file, and so the outermost class that we have here is try-catch-example, right? In this class, we have our main function, and inside this main function, we are performing some operations. So at first, we declared some variables, number and result, and the value of number is 40, right? So instead of using the try and catch block for now, let's comment this out. Suppose we want to perform this two operations. That is, we want to divide our number by 0, and then we want to print our result. All right. So obviously, we understand that this will throw an error, or this will throw an exception, because an integer value cannot be divided by 0, right? It will throw a mathematical error. So what will happen is our program will stop executing at this line, and it will say that it has failed to compile successfully. So let's see if that's what happens. All right, so as you can see, it is saying that our program is facing an error or throwing an exception at line 22, that is in this line. And the exception is java.lang.arithmeticException, which is division by 0, right? So we understand that our program has stopped executing at this line, and so it has not moved on to this print line here or to this print line here, right? So now, instead of stopping our execution at this line, what we want to do is, if it faces any exception like this, we want to execute some alternative lines of code. So the way we will do this is by using our try and catch blocks. So let's comment these 2 lines right now and uncomment our try and catch blocks. So inside our try block, we are doing the same operations as we did earlier. That is, we are dividing number by 0 and we are storing that value in result, right? And we are trying to print that result by using our system.out.println statement. Now, if our program does face any exception here in this try block, then what it will do is it will go to the catch block. So as you can see, we have 2 types of catch block here. In the first catch block, we are handling all types of arithmetic exceptions that will happen or that might happen in this try block. So as we said earlier, there might be different kinds of exceptions, and we can have different kinds of catch blocks to handle these different kinds of exceptions, right? Now we know that this line of code here, this line right here, might throw an arithmetic exception, right? So to handle this exception, we are using this catch block. So as you can see, inside this catch block, we are declaring an object of arithmetic exception type, which can handle arithmetic exceptions. So the first line in our catch block is simply printing the type of exception that we are facing. And next, what we are doing is, instead of dividing our number by 0, we are dividing it by 10. And then we are simply printing that result. All right? So this is what is happening in the first catch block. Now, for some reason, imagine that this line here does not throw an arithmetic exception. Instead, it throws some other form of exception which we are not aware of. So for that purpose, we have written another catch block where, instead of declaring an object of any specific type of exception like arithmetic exception or IO exception or SQL exception, etc., what we're doing is we are simply declaring an object of the exception type. And inside this catch block, we are simply printing that exception. All right? So now let's see what happens when we try to execute this program. All right, so let's see what is happening here. First, our program tried to execute the lines of code inside our try block. Okay, so it failed. So what it did is it went to this catch block right here. So at first, it printed the type of exception that it was facing. So error in try block, exception java.lang.arithmeticException, division by 0, right? So far, so good. Next, what we did is, instead of dividing our number by 0, we divided by 10, and then we printed the result. So 40 divided by 10 is 4, so it printed 4, right? Next, what it did is it did not go to this catch block because our exception has already been handled by this catch block, right? So the other catch blocks, or if we have any, in this case we do have another catch block, so the other catch blocks will be ignored. So instead, what it did is it went to the final line of code that we have here, which is code completed, right? So that's what it printed. So now we understand how try and catch blocks work and why exactly we need them, correct? So a common question that you might be wondering about is when we should be using this try and catch block. To understand that, we need to keep in mind that there are 2 categories of exceptions: checked exceptions and unchecked exceptions. So checked exceptions usually denote those scenarios which are outside the immediate control of the program. So they usually occur when we are interacting with external sources like an external database or network input, or taking input from an external file, and so on. So these exceptions cannot be handled by the compiler themselves. So Java forces you to handle these error scenarios in some manner in your application code. All right. On the other hand, unchecked exceptions are usually those errors or those exceptions which are not checked directly by the compiler. They usually come to life or occur in your program if your application code is buggy. So these exceptions are not mandatory to be handled. However, it is good practice to handle them either way. So some common unchecked exceptions are like the arithmetic exception that we encountered, and we also have null pointer exception and so on. So exceptions like the SQL exception that we will be seeing in our later section right now are falls under the category of checked exception, and they must be handled. All right, so that's what we need to keep in mind. With that out of the way, let's move on to actually seeing how a sample code in JDBC works. So before actually moving on to the sample JDBC code, there are a few configurations that we need to take care of. So first of all, the IDE that we are using here is IntelliJ. You can use IntelliJ Ultimate or you can use IntelliJ Community Edition. It does not really matter. If you have your EDU account, you can use that account to get a student account for IntelliJ Ultimate, right? Anyway, so whenever we install Java in our computer, we get a bunch of libraries that come with Java that help us to compile and run Java programs, right? However, JDBC is not included in one of those built-in libraries. So what we have to do is whenever we want to use JDBC in our project, we need to add it or we need to import it from an external source. So the way we do that is by adding the OJDBC jar file to our project structure. That is, if this is our project, then we need to add the OJDBC jar file to this project so that we will be able to use the libraries or to use the methods and functions that help us in establishing connection to our Oracle database. All right. So the way we can add this jar file is obviously at first you have to download the jar file, right? Don't worry, I will be providing you the jar file in your Google Classroom so you can download it from there. So after you have downloaded it, you go to File, then Project Structure, go to Modules, hit the plus sign, press Jars or Directories, and from here you select the jar file from wherever you have kept it after downloading it. All right, then you hit OK, and after that you will see that the OJDBC.6.jar file will appear here, which means that you have added your OJDBC jar file successfully. So since this is an external library that you have added, if you hit the external libraries tab here, you can see that we have our OJDBC6.jar file listed under the external library. So we can say that our jar file has been successfully added as an external library. All right. Now we can actually move on to the code and see what is happening here. So quickly, let me just show you the database that we will be working with. So let me just connect to my database. All right. So we have a table called customer. And under this table, as you can see, we have 3 rows and 4 columns. So if we were to calculate the average age from this table, we would get 30, right? So just remember this. Now, let's just disconnect from our database and move on to the actual code. So as you can see, this is our main.java file, and it has an outermost class called main, because the name of the file is main as well. All right, so inside our main function, we have 2 variables, username and password, which are basically the username and password that we will be using to log into our database. So I have kept it the same for simplicity's sake, don't judge. Next we have a variable called URL. So in this variable, just look at this URL at first. The first part of this URL is basically stating the type of driver that we will be using to establish a connection to our database. So the thin driver is a driver that is written entirely in Java, and it basically converts all types of JDBC calls into native, how should I say this? So it basically converts all JDBC calls into vendor-specific database protocol. So again, you don't need to worry about what that means. Just understand that the type of driver that we will be using is a thin driver. The latter part of this URL is basically the port number at which our database was located and the port number at which we can establish a connection with our database. All right. So since all of us will be using Oracle 11g Express Edition, this port number will mostly be similar for all of us. All right. So just use this for your URL. Next, we have another variable, SQL query. And this variable is basically storing the query which we will be executing on our database. So we will be using this query to calculate the average age from our customer table, right? And we have another variable called average age, and we will simply be storing that average age in this variable later on, you'll see. So now starts our try block. So the first thing that we need to do is we need to register our driver. So if you remember, we added our OJDBC6.jar file as an external library to our project, right? However, our project is still not aware that it needs to use that driver to access our database. So what we need to do is we need to register that driver class to our project so that it is aware that it needs to use that library file to establish connection to the database. All right. The next thing we have to do is we have to create the connection object. So OJDBC gives us a number of classes, and one of those classes is called connection. This connection class is used to establish a connection to our database. All right. So we have created an object of the connection class called con, and we have initialized it as follows. So as you can see, and as you can understand, getConnection is a static class of the is a static method of the driver manager class, and it takes three inputs: URL, username, and password. So what do we know about static methods? We know that static methods do not need to use any objects to be called, right? They can be called directly by using their class name, in this case driver manager. So getConnection is a static method under the driver manager class, and it takes three inputs: URL, username, and password. So URL is the same as we have defined earlier. The username is the user under which we will be logging in, and our password is simply the password of the user. All right. Next, we create the statement object. So statement object is created so that we can execute queries on our database. All right. So after we are done establishing connection to our database, we need to be able to execute queries, right? So the way we can execute queries is by using this statement object. And as you can see, we have initialized this statement object as con.createStatement. So basically, by using this statement object, we will be able to execute queries on our database. So if we have done all these three things successfully, we can say that we have established our database connection. All right, so that's why we have simply written this print statement. Now comes the fun part. Now we will be executing queries on our database. So one thing we need to remember is whenever we execute queries in our database, we are always returned a set of rows, right? So even in the case of using aggregate functions, and we are returned a single value, we can say that we are returned a single row with a single column, right? So the gist of this discussion means that whenever we execute a query on our SQL database, we are returned a set of rows, and this set of rows needs to be stored somehow, right? So the way we can store this set of rows is by using the result set class. So we declared an object of the result set class called result, and we have used the previous statement object that we have declared to execute our query. So execute query is a method of the statement class, and this method takes as input the query that we want to execute. So if you remember, the query that we have defined earlier is select average age from customer. So this is the query that we will be executing by using the execute query method under the statement class. All right. And the result of this query will be stored under this result object. Okay. So we know that a query may return multiple rows, right? So to traverse all those rows, we write a loop, or we use a loop. But in this case, we know that our result will contain only a single row with a single column, so we can say that this loop will run only once, correct? So whenever we write result.next, this basically means that it will traverse through all the rows, and it will run, basically the loop will run however many times, however many rows we have in our result set. All right. So inside this loop, we are basically storing the age value, or the average age value that we are getting from our query inside the average age variable. All right. And the way we are accessing that value is by using the getLong method. So we know that average age is a double or a float value. So we have used the getLong method. If we wanted, we could have also used the getDouble method. All right. And inside this method, as parameter, we are passing the column number that we want to access. So in this case, the column number is 1, right? Because it is a single column. If there were 2 columns, and if we wanted to access the value of the second column, we would have simply written here 2. All right. Next, we have a print statement, which is basically just printing the average age that we have found from our query. And there, we are done executing the query. So now that we have finished working with our database, we need to be sure that we close the connection to our database, right? So the way we can close our connection is simply by calling the close method under the connection class. So the object of connection that we had is con, so we simply write con.close. We also need to close our statement and result objects, so we have written those statements as well. However, whenever we execute this statement, the con.close statement, our statement and result objects are closed automatically. So if we want, we can comment this out as well. So finally comes our catch blocks. So obviously, one of the exceptions that we need to handle in this kind of operations is SQL exception, right? SQL exception can occur whenever our database fails to establish a connection to whenever our program fails to establish a connection to our database, all right? The other type of exception that we need to handle is called class not found exception. So this type of exception can occur whenever our program fails to register the Oracle driver, all right? Now let's run this code and see what happens. Okay, let's just bring this up. All right, so as you can see, our connection to the database is successful and we got our average age, right? So let's perform some experiments now and check whether our exceptions are working properly or not. All right, so let's change our username here. So we should not be able to log into our database now, correct? So let's see if our exception works. All right, so as you can see, our program failed to connect to the database, and so this exception has been handled by the first catch block that we defined. So as you can see here, error while connecting to database, exception code, SQL exception. And we have also been given the error that we are facing, that is invalid username password. So let's just fix that up. As for the second exception that we are handling, we can't exactly test that out for now. However, let's see if we actually have this class file under our JDBC jar file, right? So oracle.jdbc.driver.oracle-driver, right? So let's see, Oracle JDBC driver, and let's see if we have any class named Oracle driver here. So yeah, as you can see, we do indeed have a class named Oracle driver under our JDBC jar file. All right, so we can say that we will not be facing any error that will come from this statement. Anyway, let's also change up our query and see what happens. So the age values that we had in our database were 25, 30, and 35. So our sum should be 90. So let's say if we get 90 as the result right now. So yeah, we are getting 90. So anyway, now we understand the basic structure of a JDBC code, and hopefully we will be able to use this code in our future projects, right? Okay. A few things before I end my video. So in this video, we have obviously looked at a bunch of topics like try and catch, static methods, and so on, right? So there is definitely a more detailed and thorough explanation that needs to be had whenever we are dealing with these topics. However, since those were not our main concerns, we overlooked a lot of things, right? So the way I explained those things should not be taken too seriously and should only be used as a reference to understand superfluously the topics that we discussed today. Also, whenever I use any definitions or use any terminologies in my videos, do not use them as a substitute for your official theoretical definition or the definitions that you learn from your theory classes in your examinations, all right? So always use your official theoretical definitions and explanations whenever you are writing anything about these topics in your examinations or in your viva, all right? So take care, and I hope you understood everything that we discussed today. And in case you have any question, then don't hesitate to leave a comment here or ask me during our live sessions. All right, so take care.